Well, of course, we have to attach numbers to things because that's one of the things that chemists do. So we measure solution concentrations in different ways. One way is a mass percent. So this is measuring solute and solvent in terms of their mass. And remember, percent is parts per 100 parts, or parts per the part over the whole times 100. And so we would take the mass of the solute and divide by the mass of the solution, which is the solute and the solvent. So this is the whole thing, the mixture, and this is the mass of the solute that we're interested in. We find that ratio, we multiply by 100. And that gives us the mass percent. So if we have a 14% by mass solution, is going to have 14 grams of solute per 100 grams of solution. And mass percent is a very convenient concentration. It's used a lot in medicine and technical fields. It's not used as much in chemistry. Calculate the mass percent of a sucrose solution containing 11.3 grams of sucrose and 412.1 milliliters of water. Assume that the density of water is 1 gram per milliliter. So they're asking us for mass percent. So then we say, well, what is mass percent? It's going to be the grams of solute divided by the grams of solution times 100. What is the mass of the solute? $11.3. There's 11.3 grams of sucrose, that's the sugar. What's the mass of the whole solution? Did they tell it to us specifically? No, they're going to make us calculate it. We have this volume of water, and we're told to assume that the density is 1 gram per milliliter. So 1 gram per milliliter, so 412.1 milliliters times 1 gram per milliliter. How many grams does that get us? Four hundred 412.1, right? Now, do you really have to write that out? Probably not, but there it is. So that is the mass of the solvent. The solution is the solute, what's dissolved in it, and the solvent. So we need to add the solute to get the mass of the whole solution. And 423.4 grams. So 423.4 grams is the mass of the whole solution times 100. You should never have a percent by mass that's greater than 100. 11.3 divided by 423.4. So 2.67%. Anybody else get that? 2.67%. Any questions? Other units that are commonly used, parts per 100, that's actually the same as percent. Parts per million and parts per billion. These are related to percent, but instead of parts in 100 parts, parts per million, which is abbreviated ppm, is the number of grams of solute per 1 million grams of solution. And parts per billion is grams solute per 1 billion grams of solution. These are used for very, very small concentrations. If you look at the annual report you get from the city specifying all the contaminants in the water and stuff, you'll see a lot of parts per million and parts per billion units, because there's stuff in the tap water, but very, very little. We can use mass percent in calculations, and when you see a mass percent, remember that that means grams per 100 grams, and that makes it very quickly into a useful conversion factor. So how much sucrose in grams is contained in 355 milliliters of a soft drink containing 11.5% sucrose? And so this is like a 12-ounce can of soda, and we're going to figure out how many grams of sugar are in it. Here they're telling us to use a density of 1.04. We're using 1.04 instead of 1 because this solution has quite a bit of sugar in it, and so the density is going to be higher. So we should take this number, 11.5%, and write that as a ratio. 11.5% means 11.5 grams of solute, which is the sucrose, per 100 grams solution. That's a conversion factor. They're giving us a volume of soda, 355 milliliters, that's the solution. And they're giving us a density here. I'm going to write that out vertically as well. 1.04 grams of solution per milliliter of solution. So we're going to take this 355 milliliters of solution, the soda, and we're first going to convert to grams. So milliliters cancel out. And then we're going to use that mass percent, 11.5 grams of sucrose per 100 grams of solution. Writing too big today. So 355 milliliters times 1.04 times 11.5 divided by 100. 42.5 grams of sugar. It's a lot of sugar. One can of soda. Any questions? This is dimensional analysis. Looking at the units, combining them to convert from one to another.